going to perform the design thinking based role play on smart fan control using time response analysis. In this role play, we are going to explore the rise time, peak overshoot and settling time for time domain specifications. For this role play, now we move on to the one real life problem.
Why is the fan like this? First it's too slow, then suddenly it becomes fast. I just want a normal speed.
This is a real life problem. Many systems fail due to poor time response.
I don't know all that. I just need a comfortable speed.
Guys, don't worry. We can solve this problem by using design thinking and control system.
Based on the empathy part, now we are going to define the problem statement for this role play. Arvind, can you define the problem statement of this?
Yes, on define, by analyzing the issue, we have find these are the issues in this problem. And the first issue is high rise time, which causes a slow start in the fan, and high overshoot, which causes the fan to run in a overspeed or too fast, and poor settling time, which causes the fan to run in an unstable speed, and the slow and speed motion of the fan is the main issue in this problem.
So a question arises. How the fan would reach its desired speed without overshooting or overloading? How will it reach?
Okay, now shall we design something new? I have an idea. Instead of letting the fan run blindly, why don't we make it smart using a feedback control system?
Okay, then now we can measure the actual speed and then compare it with the desired speed.
Yes, the speed can adjust automatically.
What? So the fan can run automatically.
Exactly, it's a smart system. The prototype using a block diagram. So when the desired input is given, the controller controls the voltage so that the motor runs, and the desired output is reached using the feedback system. Now this will be furtherly explained by the narrator.
So let's see. So here we have the block diagram of this control system. First we have the input. So the input we are giving is the reference input. So let's say we are giving 1500 RPM. So that's the reference input we want. And next we have the controller. The controller decides whether what should be given. So the reference input next go to the controller. Then the controller gives the input to the motor. The motor starts running. Then the speed of the motor, which is the actual speed, is the output we are getting. Then the actual speed of the rotor is given as the feedback. Again it runs in a circle. So as we saw, we are giving 1500 RPM as the control, as the reference input. Here we get the motor output, which is the actual value as let's say 1450. So that is we see there is an error between the desired value and the actual value, which is a 50 RPM. So for correcting this, we are using a feedback system. So this is the simple explanation of this block diagram.
And as the narrator said about this control system, and this prototype is taken as a second order system.
By adjusting the damping ratio, we can control the behavior of the fan.
So will it stop the fan from being crazy?
Yes, we'll test this.
Test different responses. In first case, we are going to test low damping.
The speed of the fan is really high. I can't handle this.
In second case, we are going to test optimal damping.
The speed of the fan is perfect, it's comforting, and the speed is right.
And let's test the third case, high damping.
The speed of the fan is really slow. I can't handle this and it's sweating.
So the best performance is low overshooting, fast settling time, best balance time.
So this shows how time response analysis affects real life problems.
By controlling rise time, overshoot and settling time.
And finally, we have improved the system's performance.
And we have created a smart solution.
So finally, there is a fan that understands me.
So now let's conclude this role play. So in time response analysis, we discussed about the time peak overshoot, and rise time, settling time and maximum time period for this response. So from this role play we can understand the every time domain specifications and we provide a smart solution for this role play. Thank you.